Hello, my name is Scott Crawford. This is assignment 9 for game engine and design. And in this assignment, we were told to implement frame culling based off the frustum of the camera and where the player was looking. So for this assignment, I took the city that I'm currently generating and I implemented a frustum based on where the camera was rendering, and I gave it a set amount of distance for everything. So as you can see, each of these roads is one cell. And as I cross the threshold into another cell, it'll spawn in the next one because that's my current view distance that it's set at. And if I turn to the side, the same thing will happen as I move in any other direction. So as the player is moving around the city, it only spawns in the cells that are around the player. And the way this works is that my player is being isolated down to a singular cell, and it takes in the what direction it is looking, not including the y-axis, and it will spawn cells forward away from the player. Now, if I were to zoom out, I can show you this in progress. You can see that the cells behind me are not actually spawning, and as I turn to look around, it is shifting the angle that it is spawning to look at. So only those cells are going to render. And as of right now, there's a little over 6,000 to 12,000 objects currently being rendered at once in this entire city. And so I'll move back down. And so you can see the frame color. I can still have moving animations, and I can still see some chickens moving around. And furthermore, if I were to, I can modify all these values for my frustum. I can edit the view distance. And if I zoom out, I can show you what I mean. Normally, because the camera is so close down to the ground, that I can change the amount of width or how far apart that we draw. So I can modify my frustum based off how high up the camera is to include a more amount of width to make sure that all objects are filling up the screen. And in addition to this, I can also add another frustum in to look at different parts of it. So I can add in what I like to call the dummy frustum or the secondary frustum. And if I'll add it at the cell 00, so it should be right over here in that cell, and I'll have it look east, and if I add it, it'll start drawing. And now if I move away from this, slowly the cells will start to disappear, and you can see that it is only looking in that direction. I might have to turn down my view distance though. So yeah, you can see that is my frustum over there. And if I were to change the direction, say for instance, making it go south, I can make it go east, west, north. You get the idea for it. So I can move this frustum around. Like say for instance, if I start moving it down the x-axis, it'll start moving down here. I can move it back down to 0, and I can move it down the z-axis as well. And behind the scenes, the way this whole thing works is when the city is generated, it generates an entire layout. And this entire layout dictates where to spawn every object, how each building is supposed to be made, and that big extended grid is then converted down into 8x8 cells. And these 8x8 cells can have a list of every matrix for what type of object is in there. And then it determines where the player is, and it renders only the squares in front of me, or it renders a cube around me to do the turning. So depending on how fast you turn, it will not have pop in directly around the player. Now if I zoom out, I can see that here is all the objects being run at once, and it drastically reduces my frame rate. And if I were to go back to my frustum, it will vastly improve my frame rate. And if I look away from it, you can see in the top left that my frame rate is going back up. And if I look back towards it, it goes down. And it's correctly calling out all the objects that it does not need to render. There is a little bit of a bug sometimes with some of the moving objects not being determined of their exact locations, but it appears to only happen with that one variety of chicken. And this is my assignment number 9 of frame culling, and the example of it in my current final project. This is Scott Crawford.